Today I'm going to be talking about section 7.3, which involves sum and difference identities. Here's a list of all the sum and difference identities. You'll notice that the identities all look quite similar. Those for the sum and difference identities for sine and also for cosine. Tangent looks quite a bit different, but it's kind of hard to remember the identities because, again, they are so close. So in a minute, I'm going to show you a little story that will help with that. With the sum and difference identities for tangent, these two look similar. I'll tell you a little bit how I remember them. This plus sign that's in the middle, that goes in the numerator. Whatever this is the sign in the denominator is the opposite. So notice for the difference identity for tangent, the minus matches the numerator. The opposite is in the denominator. Other than that, they look identical. And I have posted an identity sheet on Schoology, so you can pull that up and look at it anytime you want. But as I've said before, it is easier to do these problems if you remember them quite well. So I would spend some time studying just to have a pretty good idea of what all the identities are and be able to recognize them. Now, here's the story. So I found this at a conference one time, and it really does help me remember what they are. It's a true love story. It's too bad it's not near Valentine's Day. That would be nice, but still a love story is nice whenever you get it. So this is the story of Sinbad and Cosette. Sinbad loved Cosette, but Cosette did not feel the same way about Sinbad. Naturally, when Sinbad was in charge of their double date, he put himself with Cosette and he put his brother with her sister. So you can see Sinbad is here. He's in charge of the double date. He puts himself with Cosette. He really likes her. And he puts Cosette's sister with his brother. Sinbad loved to tell people that his and Cosette's signs were the same. Notice, this is a plus sign. This is a plus sign. This is a minus sign. This is a minus sign. However, when Cosette was in charge of the double date, she placed herself with her sister and put Sinbad with his brother. She made sure that everyone knew their signs were not the same. So here's Cosette. She's in charge. Cosette is with her sister. Sinbad is with his brother. Their signs are not the same. Plus, minus, minus, plus. Also notice that Cosette placed herself and her sister before Sinbad and his brother. This detail was important to Cosette. She was very snobby, you know. Now, if you like the story, that's great. If you don't like the story, that's fine too, but find a way that's going to help you remember these identities. All right, so I'd like to do an example first where we are using our sum and difference identities to figure out what cosine of A plus B and sine of A plus B are when I'm given a little bit of information about some trig functions involving A and trig functions involving B. So we are going to first draw ourselves a picture of A. And it was nice. It told me A was in quadrant 3. So I'm going to draw it there. And I'm actually going to put the name next to it so I don't forget. And luckily, this matches with our expectation for the sign because sine is negative in quadrant 3. If it didn't, that would mean it's a bad problem. And I'm going to draw myself an altitude to the x-axis. And then I know that sine is the opposite over the hypotenuse, or y over r. R is always positive. So y is negative 5, r is 13. So then we're going to use Pythagorean theorem to help us find x. So we would know that the hypotenuse squared equals leg squared plus leg squared. So 13 squared would equal negative 5 squared plus x squared. And so that's 169 is equal to 25 plus x squared. Subtract 25 from both sides. You'll find that x squared is 144. Take the square root. x equals plus or minus 12. Now, since it is in the third quadrant, I know that x has to be negative. The other way you could have recognized what x was is recognizing this as a Pythagorean triple. This is a 5, 12, 13 triangle. Now, the next thing I'm going to do is I'm going to draw cosine of b, and b is in quadrant 4. So we're going to draw that in quadrant 4. Again, dropping my altitude to the x-axis. And cosine of b is 7 over 25, or x over r. This is 7, 25, and again, I can use Pythagorean theorem, or I could recognize this as a triple. 7, 24, 25, so y is negative 24. And this was for b. Now, you might be wondering, why in the heck did she do that? Well, that is because I'm looking for cosine of a plus b and sine of a plus b, and I know the formulas for those. I know that cosine of a plus b, using my sum and difference identities, is cosine of a cosine of b. Remember, Cosette was with her sister. Their signs are not the same. Minus sine of a sine of b. Sinbad is with his brother. Now, I do know what sine of a is, which is awfully nice. Oh, I don't like that that's blue. Let's make it yellow. So I know what sine of a is, and that is going to allow me to fill in that part of my formula. And I know what cosine of b is, so that will let me fill in that part of my formula. But what I'm missing is cosine of a and sine of b, and I can find that from the triangles that I drew up here. So without pausing, I'm going to find cosine of a. Cosine of a is x over r, so that's negative 12 over 13. And I also need to find sine of b. Sine of b is y over r, so that's negative 24 over 25. Now I'm going to have all the information I need to fill in my formula. So, ready to fill in? Here we go. So cosine of a, we know, is negative 12 over 13. Cosine of b is 7 over 25 minus sine of a, which was negative 5 over 13. Sine of b is negative 24 over 25. And at this point, I like to plug it into my calculator. Remember, your calculator knows the order of operations. So I would do negative 12 divided by 13 times 7 divided by 25 minus, now the negatives multiplied are positive, so I'm just going to put that in my calculator, minus 5 divided by 13 times 24 divided by 25. Now, I'll get a nice decimal, but I can convert that to a fraction by doing math enter, enter, and I find that that is negative 204 over 325. So, now I found cosine of a plus b. I'd like to find sine of a plus b. Same kind of idea. I'm going to write down my formula, sine of a plus b. Remember, Sinbad is with Cosette. Their signs are the same. And now I'm just filling in values. Sine of a is negative 5 over 13. Cosine of b is 7 over 25. Plus cosine of a was negative 12 over 13. Sine of b is negative 24 over 25. And again, I'm multiplying, so those both become positive. So again, in your calculator, you would do negative 5 divided by 13 times 7 divided by 25 plus 12 divided by 13 times 24 divided by 25. And getting that decimal, I'll change it over to a fraction, math enter, enter, and I find that this is 253 over 325. Now, so I found two values that I wanted to find, but also it asked me the quadrant that a plus b terminates. So that's just asking me what quadrant is a plus b in, and I've got to use what I know about signs of trig functions. So if I know that cosine is negative, that tells me that my angle is either in the second or in the third quadrants, because that is the portion where x is negative and cosine is x on the unit circle. The next piece of information I have is that the sign of a plus b is positive. Now, sign is positive here and here. So therefore, I know that my quadrant for a plus b must be quadrant 2. And that is how you use your sum and difference identities to find some values. I want you to give this one a try. Press pause on your video, and when you're ready for the answer, press play again. Double check. Yep, A is in the front. I was told that you can see my answer here. Again, I drew triangles for A and for B. I knew that A was in the first quadrant. I believe they told me that. Quadrant, I knew that sine was 3 over 5. 3 is y, 5 is the hypotenuse. So that becomes 3/5. Cosine, using Pythagorean formula, I find that this is 4. So cosine of A is 4 over 5. B was in the second quadrant, and I had cosine of b, that was negative 5 over 13, x over r, negative 5 over 13. Sine of b, using Pythagorean theorem, I know this must be negative 12, so sine is negative 12 over 13, opposite over hypotenuse. Now I'm plugging into each of these formulas. I have all the values I need. Plug in, put it in my calculator, I should get 16 over 65. For sine of a plus b, same kind of idea, negative 63 over 65. Now again, a plus b is in quadrant 4. This is why. If I know that cosine is positive, cosine of a plus b is positive, that means that my angle is either in the first or in the fourth quadrant, because that's where cosine is positive. Sine is negative. Well, that means my angle is here or here. So a plus b must be in quadrant 4. The other thing we can do is we can use sum and difference identities to evaluate trig functions and get exact answers. So the key here is to rewrite pi over 12 as either a sum or a difference of angles that we know on the unit circle. Now let me show you how I determine what those are. So I know that this angle is pi over 6, this is pi over 4, this is pi over 3, this is pi over 2, and sometimes I don't have to go past there, so we'll stop there for now. And then I take each of those angles and I write it with a denominator of 12. So this is 2 pi over 12, this is 3 pi over 12, this is 4 pi over 12, and this is 6 pi over 12. Now there's going to be lots of different choices I can make, and it doesn't matter which you choose, so long as the difference or the sum is the same as what you're looking for, you'll get the same answer. So I notice that, 3 pi over 12 minus 2 pi over 12 is pi over 12. So that's the one I'm going to use. So I'm going to rewrite this as sine of pi over 4 minus pi over 6. Now, I'm going to use my identity. Remember, we need to use the difference identity for sine. And Sinbad is with Cosette. Their signs are the same. And now A is pi over 4 and B is pi over 6. So I am simply plugging in. So I know this is sine of pi over 4 cosine of pi over 6 minus cosine of pi over 4 sine of pi over 6. Now this comes back to the idea that you need to know your unit circle quite well and know what the standard angles are, the trig functions are for the standard angles. So I know that sine is at pi over 4 is square root of 2 over 2. Remember the coordinates here. Square root of 2 over 2, comma, square root of 2 over 2. The coordinates for pi over 6 would be square root of 3 over 2, comma, 1/2. Now, sine is the y-coordinate on the unit circle. That is where this came from. Cosine of pi over 6, cosine is the x-coordinate on the unit circle. So I know that this is the square root of 3 over 2. Minus cosine of pi over 4, again, x, square root of 2 over 2, times sine of pi over 6. And sine is y on the unit circle, so that's 1/2. So this is the square root of 6 over 4 minus the square root of 2 over 4. And I'll write that with one denominator. And this is the exact answer for sine of pi over 12. Here's another one. I'd like to find the exact value of sine of 75 degrees. Just like I can work with radians, now I'm working with degrees. I'm looking for two angles that either add to 75 or whose difference is 75. And I'm going to think about my unit circle. This is 30 degrees. This is 45 degrees. Oops, found it. So it's going to be 75 is the same as 30 plus 45. There's other ways to do it. You get the same answer, but those are the first two that I think of. So I'm going to rewrite sine of 75 as sine of 30 plus 45. Now remember your sum and difference identity, your sum identity for sine. Sinbad is with Cosette. Their signs are the same. And then I'm just going to let A be 30 and B be 45. So this is sine of 30 cosine of 45 plus cosine of 30 sine of 45. So again, I have to remember what my coordinates are here. This is square root of 3 over 2, comma, 1/2. And then at 45, it's square root of 2 over 2, comma, square root of 2 over 2. So sine is y on the unit circle. So sine of 30 is 1/2. Cosine's x. Cosine of 45 is the square root of 2 over 2. Cosine of 30, cosine's x, that's the square root of 3 over 2. And sine of 45, again, sine is y. That's square root of 2 over 2. So I find that this is square root of 2 over 4 plus the square root of 6 over 4. Writing this over one denominator gives me that. So sine of A plus B is the square root of 2 plus the square root of 6 all over 4. I'd like you to give this a try. Press pause on your video. When you're ready for the answer, press play again. So you'll notice that I started off by just drawing in the angles that I knew on my unit circle. I rewrote everything with a common denominator of 12. And then I noticed that 3 pi over 12 minus 8 pi over 12 was minus 5 pi over 12. And that was pi over 4 minus 2 pi over 3. Then using the difference identity for sine and letting A be pi over 4 and B be 2 pi over 3, I rewrote it. Sinbad's with Cosette. Cosette is with her. Cosette's sisters with his brother. Their signs are the same. So I know that sine of pi over 4 is square root of 2 over 2. At 2 pi over 3, my coordinates are negative a half square root of 3 over 2. So cosine of 2 pi over 3 is going to be the x coordinate, negative a half. Then cosine of pi over 4 is square root of 2 over 2. Sine of 2 pi over 3 is square root of 3 over 2. And then I just simplify. Now we're going to go in the reverse order. I would like to find the exact value for this expression. Now you should look at this and recognize it as one of our sum and difference identities. This happens to be the difference identity for cosine. Cosette is with her sister. Their signs are not the same. So looking at this, I know that A is 78 and B is 18. So I can rewrite this as cosine of 78 minus 18. Well, 78 minus 18 is just 60. So this is the same as cosine of 60. Thinking about our unit circle, at 60 degrees, my coordinates are half square root of 3 over 2. So cosine is x, so cosine of 60 is a half. Now I'd like to find the exact value for this expression. This looks a lot like the sum identity for tangent. Let's write that down. Tangent of A plus B equals tangent of A plus tangent of B over 1 minus tangent of A tangent of B. So it looks very similar, but not exactly, because look at the denominator here. This product here is positive while the 1 is negative. So what I want to do is adjust this expression so that I can make a substitution. So I'm going to factor a negative out of the denominator. So this is tangent of 80 plus tangent of 55 over, factor out a negative, tangent of 80, tangent of, actually this is negative tangent of 80, tangent of 55 plus 1. Now I'll rearrange a little bit. This minus, I'm going to move out to the front. This is tangent of 80 plus tangent of 55 over 1 minus tangent of 80 tangent of 55. And there you go. Now it matches exactly. I can let A be 80 and B be 55 and make a substitution. I got to remember I have this negative sign out front. So this is negative tangent of 80 plus 55. So adding those two together gives me negative tangent of 135. Now I've got to remember my unit circle. At 135 degrees, that's right over here, and my coordinates there are negative root 2 over 2, comma root 2 over 2. So tangent of 135 would be y over x, so that's negative 1 there. So this is negative of negative 1, or just 1. Now we're going to simplify this. Again, we're going to use our sum identity for sine. Sine of A plus B is equal to sine of A cosine of B. Cosette is with Sinbad, and their signs are the same. Cosine of A, sine of B. Now, I'm going to let A be x and B be 3 pi. So this becomes sine of x cosine of 3 pi plus cosine of x sine of 3 pi. Now, I've got a picture where the 3 pi is on my unit circle because I'd like to evaluate cosine of 3 pi and sine of 3 pi if at all possible. So picture the circle. All the way around is 2 pi, and then another halfway around is 3 pi. So my angle is sitting here at the negative side of my x-axis, and the coordinates there are negative 1, comma 0. So sine of x just stays sine of x, but cosine of 3 pi is the x-coordinate on the unit circle at 3 pi. My x-coordinate there is -1. Plus cosine of x, that stays the same. And now I need to put in a value for sine of 3 pi. Remember that sine is y, so this is 0. So this simplifies to negative sine of x. I'd like you to take a look at this identity and try to verify it. You can start on the left or start on the right. Now, before you start going, I want you to notice something. Usually I tell kids to work with the most complicated side first, but this is an exception to that rule. So the first thing you want to do is rewrite cosine of x plus x. Then you're going to use the sum identity for cosine to rewrite that and hopefully arrive at the right side. Now, finish it, press pause on your video, and when you're ready for the answer, press play again. Here is the answer. You'll notice I rewrote cosine as cosine of x plus x, and then I used the sum identity for cosine. That is cosine of A plus B. Cosette is with her sister. Their signs are not the same. Sinbad is with his brother. So I let A be x and also B be x. So substituting in, I had cosine of x times cosine of x minus sine of x times sine of x. That's cosine squared x minus sine squared x. Okay, next I want you to take a look at your assignment online and have a great day.